Next up is Saurabh, and Saurabh's going to be talking about disaster management and open data.
Thank you. Hi, can I? Okay, I'm audible. Sure.
15 minutes, that includes your question time.
Yeah, sure. Okay. Okay, so hi everyone. I'm Saurabh. I work with an organization called Civic Data Lab. And I'm here to talk about one of our projects that we developed, which is essentially developing a flood data ecosystem for disaster risk reduction. It's a project called IDSDRR. It's a bit of a mouthful. Essentially, so Civic Data Lab is a social enterprise. We're focused on basically enabling data change makers to leverage data and AI to drive social good across India and across the world. We work across a number of pillars, primarily in public finance, digital public goods and infrastructure, few others. And today I want to talk about one of our projects, which is more in the climate action sphere. So I think living in India, we all know about the issues with climate change. That primarily one of the biggest problems is with hydrometeorological disasters, especially flooding and cyclones. But this problem is compounded by the fact that there don't exist good data resources to enable effective flood management measures and risk mitigation strategies. And just taking examples of from how we work on the ground, this is looking at one of the states we work in Assam. Essentially, this is how data is stored. It's in boxes, it's in files, it's existing in silos in different departments, and essentially data is not talking to each other, and it's hard for departments to work together to actually come in on the ground and develop the capacity that they need to actually address disaster related issues. So this is kind of where we jumped in with our project. It's called IDSDRR, or the Intelligent Data Solution for Disaster Risk Reduction. So it consists of three components. One is a climate data exchange. So we have collated data from various different sources and transformed it, cleaned it, so that it can be used for climate action more effectively. We've also developed an AI model for risk assessment, which will help authorities in the state disaster management authorities actually identify geographies which are at risk and be able to prioritize resource allocation in those geographies. And we have also modeled our platform around the Sendai DRR framework, which basically there are a few components. One, it looks at risk as a component of sub-factors. One is of hazard, which is the geophysical properties that result in a certain disaster. Then there's exposure, which is the population and the assets that are exposed to disaster. And there's vulnerability, which looks at socioeconomic vulnerability as well as losses and damages and infrastructure access and a number of different aspects. And finally, government response, which is looking at what sort of resources does the government have to actually to respond to a given disaster. And through this methodology, we want to move the focus in disaster planning away from impact management to actually long-term capacity building and preparedness. So I can show you a platform. This is, hopefully it's visible. Yeah. So it consists of an analytics layer. Essentially, you can dive into different geographies and yeah. So in this case, you can see that Sibsagar looks like the overall flood risk is very high. You can dive into Sibsagar, see what factors are contributing to flood risk. In this case, it's government response, which indicates that maybe they don't have the funding required to actually respond to a flood situation. So you can dive into that. And yeah, it seems like they don't have flood tenders. They don't have state disaster relief funds available to respond in a given situation. And similarly, you can dive down at the district and sub-district levels to actually understand what sort of factors are impacting flood risk. You can also do a sort of time series analysis. Again, taking Sibsagar as an example. Select. You can look at overall flood risk. You can also compare risk over months, etc. So there are different modalities you can use to actually analyze the data. And finally, this is the flood data, the ecosystem that we've developed. So all the data is actually accessible on the platform. You can go in and both the transform data as well as the raw data that we've scraped from these platforms. You can go in, analyze it, see whether it fits your needs, and essentially we really want other people outside of just the state disaster management authorities and us to be using this data towards public good. So please feel free to access it and do what you build use cases around it. And again, all the data and all the scrapers, everything is accessible on GitHub. You can dive. This is a repository for Assam. We also have similar repositories with the other states we're working with in UP, Bihar, Himachal Pradesh, and Odisha. So this includes both the data that we're using into our platform as well as the scripts to actually access the data and analyze it. So there are a number of use cases. We think especially our tender scraper would be very useful in different contexts to understand what different public procurement practices. So please do feel free to use it and fork it for your needs. So yeah, just kind of giving an overview of what the flood data ecosystem is. We kind of we mostly work with governmental sources, and it's a range of one-time and monthly sources. We typically update the data model on a monthly basis, so that's the kind of resolution we're working with. And we're looking at one of the main data sources is flood-related funding. So just kind of giving you an example of how this works. We extract data from we scrape data from the JEPNIC portals, the e-tender portals of every state. We extract indicators from these data sets. We develop a risk score for each sub-factor. And these are all combined using a Topsys model into a cumulative monthly risk score. And this essentially is the structure. So we're looking at various different features from geomorphological data, population and demographics, infrastructure, and losses and damages, which isn't in the public domain, but we have to work with the state disaster management authorities to actually access the data. And we build MOUs around that. So can I just talk a bit about some of the challenges we face with data? So no, this is like just a abstracted version of the pipeline. One is actually accessing the raw data, cleaning, extracting the indicators, transforming it to the relevant spatiotemporal resolution, at which point we get the monthly and sub-district level data, which we then feed into a risk score model. One of the biggest problems, as you know, working with government is just accessing data. And for us, the biggest way we could actually get around this was developing relationships with the disaster management authorities and with key people in the government who would actually champion our cause and help us actually get access to the things we need. And another key factor here was actually the existing open data ecosystem that we were able to gain access to. So there are data sources such as WorldPop, Sentinel, etc. And we could access these open data sources to create a pilot of our disaster risk analysis platform. And this was very helpful for the government themselves to be able to see that there is value in this data sharing process. If we just went in with the request, we would probably get dismissed right away. But then I think going in this manner actually helped us get a lot more access. And also identifying champions. This could be in any level of the government. It could be in the highest level. For example, in the ASTMA, we had the CEO himself actually championing a cause and taking us to different locations and helping us get MOUs. But sometimes even if it's more the middle management of the government, they can kind of help us get those key meetings and build up those relationships in a softer manner that actually helps us in the longer term. Finally, another big issue we're facing is often with just the methodology that we're using for analysis, because we kind of work in an iterative process where we're showing the data, the results of our models to the ASTMA, trying to get them to validate it, and so trying to build that level of trust where they also understand the insights and understand the modeling methodologies that are being used was a bit of work. We had to make sure that it was easily explainable, that it wasn't just this black box model that they don't know what's going on with it, and it was easily explainable to them. Another thing is in ground truthing. How do we know that the data, the insights from our data model are actually making sense and lining up the reality? Unfortunately, there's no clear way to do this right now because there aren't exactly risk risk models that we can compare against for these very localized contexts. So in this case, we again have to work with the state disaster management authorities at the district level and just go to them and ask them, does this line up with what your expectation is? Is this sub-district of yours actually facing this level of flood risk? And is it these factors that are contributing it? So we kind of have to do these exercises for validation. Yeah, and I think one thing that has helped us also is a more sort of iterative process where we're constantly we're building basic models, we're showing them to the authorities, getting their feedback, and having these consultations, which helps to kind of build it up into something that's more usable in the long term. We also try to cater to their custom requirements in different cases. For example, But the site development also helps because in the case of Himachal Pradesh, we weren't able to get access to key losses and damages data. So we had to kind of keep coaxing them, getting to try to get API access. They weren't able to do that. Then they finally gave us a data dump, which was completely unusable because we did not know which disaster certain types of damage were associated with. And finally, they just got so frustrated, they just gave us backend access to their server, and we were like, okay, this doesn't seem like the best idea, but it's getting our work done. So yeah, great. But yeah, that's it. The cited process kind of help us identify what works in each given context. So yeah, all our data sets are platform. The technology is all open source. They are they're shared in various open source licenses. Data sets available are in either in government or open source licenses or CC by SA. We typically sign MOUs with the disaster management authorities for sensitive data access. We try to remove any traces of PII, and all data is anonymized before it actually feeds into our risk score models. And yeah, in terms of impact, we have launched a platform in Assam, and we have trained over a few hundred decision makers across different levels, from district and state levels. And they are trying to see, we are trying to see how this kind of platform can be institutionalized for more long-term disaster-related planning. As an example, this year we helped to allocate about 100 crores of SDRF funding within the state. We're hoping this can kind of build from there. While we primarily work with secondary data sources because we want to draw value from existing public data sources, we do see there's a major need and a gap currently in terms of citizen reporting and the kind of data that's actually that this is something that's not being tapped into. So we're trying to develop a citizen engagement chatbot, which would allow, on one level, also real-time alerting based on disaster needs, and also would allow citizens to report what their impact is on a more granular basis, and also maybe enable more detailed post-disaster needs assessment data sets. And yeah, we're also trying to expose into more into different geographies as well into other hazards. We're working very closely with trying to develop heat action plans with different states at the moment, and diving more into urban heat island analysis as well. And sure, I mean, we would love for people to just contribute to the data sets and to the platforms that we've developed. So please feel free to just access it and yeah, contribute as much as you can. We also have a number of articles about some of the scraping methods that we've developed and some of the tools that we developed. You can dive into those, and yeah, thanks. That's it for me.
So you have a flood prediction model and it gives you a risk score and all that.
Yes.
So recently there have been a lot of floods in different parts of the country. Have you seen your models predicting these correctly?
So we've not, we do work in Himachal, and so just one slight clarification is that we don't actually do flood prediction. We work with historical flood information to generate these risk scores, because that's what ended up making more sense towards long-term preparedness. But there is some level of validation. We haven't really developed models for states like Punjab and Jammu as yet. But in the case of Himachal, we are actively validating it with SDMAs.
Okay, just one more follow-up question. You're building a lot of data pipelines and all. Are there like standard data models or points that you're trying to collect when you're expanding it to multiple geographies and stuff like that?
Yeah, so we kind of have just in order to enable us to be able to scale it into the geographies more, but we do kind of have like a baseline version of our model that consists of a certain set of data sets that are in public access. So we do have a sort of a baseline model that can be easily ported into different states. This consists of the procurement data, the flood inundation data, some of the more basic data sets that are available. But then we try to go deeper as we start working with the state disaster management authorities. Okay, thank you so much.